This video is for Geometry Chapter 11, Assignment 11, and it is an algebra review assignment just to take a little break from the surface area and volume that we've been doing lately, and the next assignment will be an assessment for the topic. So I'm just going to pick a few of these problems at random to remind you how to do them and make sure that you are remembering some of the skills involved in the problem. If you don't feel like you need to watch this video, then just go ahead and proceed on without it. You should hopefully know how to do them already. So the first one I'm going to look at is number 6, and it's kind of set up here. Well, actually it has a typo. This should have been an 8x. I'll try to fix that, but if it still says a 6x there, then make that an 8x so it matches the equation above there. And then we took this original equation that I know the graph is a circle, and I'm going to complete the square to figure out what the standard form of the circle is. It'll look like this when I'm finished in this structure. So I know that I need to factor a problem with 8x at the bottom, and the sides have to be the same, and they have to combine to 8x, so they must be 4 and 4, and the top is 16x squared. And then for the next one, I have a negative 6y at the bottom. If the sides have to be the same, then I get negative 3 and negative 3, and the top has to be 9, so this is a 9. And then if I add 16 and 9 to one side, I have to add 16 and 9 to the other side to keep the equation balanced. So now when I go to factor x squared plus 8x plus 16, I know it's going to factor into a perfect square. And negative 24 plus 16 plus 9, these two make 25, so then this is just 1. And to get x squared plus 8x plus 16 to factor, I would use the pieces in this diamond and do the greatest common factor, and you will find that you get x plus 4 and x plus 4, and so this is x plus 4 squared. Now hopefully you don't need to keep showing out these steps every time you need to complete the square, because I know that the first times the first has to be y, and that the number here, when I multiply it times itself, I have to get a positive 9. And because that's a negative 6y, this is going to need to be a minus 3. And I could show out the steps for that. Y squared minus 3y plus 9. So if you're unsure, just show them out. It's not a big deal, just probably there's not enough space on the handout. So if you're trying to do the work on the handout, you might grab a piece of scratch paper for that part. All right, so then once you get there, the center is at negative 4 and positive 3. Even though this is a plus, the center ends up being at the opposite of that. This is a minus, the center is the opposite of that. And the radius, this wasn't the best example to choose because the radius is equal to the square root of whatever this number is. So r squared is equal to 1, but in this particular case that also means that r is 1. So if this had been 16, then the radius would be 4. If this had been 25, then the radius would be 5. So just a little reminder on that. So then when I go to graph this, I'll go over 1, 2, 3, 4, and up 1, 2, 3, and then put on a radius of 1, and sketch a circle. So hopefully that's enough of a reminder on how to do that type of problem. When you get down here, it's more review of circles, and you're just trying to write the equation of the circle in this standard form. So you need to identify the center and the radius, and it looks like it's over 1, 2, 3, 4, and up 3. And so this will be x minus 4 and x minus 3, since these are both positive and these are always the opposite. And then the radius is 1, 2, 3, 4, which means that this number has to be 16. All right, I'm going to leave you to finish some of those others there. And now let's look at page 2. And on page 2, I thought it would be good to remind you of some of these, but maybe with an example rather than just doing the homework problems. So what if you had 2 to the third power? Well, that would mean 2 times 2 times 2, which would be 4 times 2, or 8. And what if you had 2 to the negative 3 power? Hopefully you recall learning that 2 to the negative 3 is the same as 1 over 2 to the third. And so 2 to the third is 8. And so 2 to the negative 3 is equal to 1/8. And if you had 2 to the 0, or anything to the 0 power, that is equal to 1. It doesn't mean 2 times 0, it means 0 factors of 2. And it's difficult to discuss in this format, but if you wanted something to be neutral and to not impact a multiplication problem, and so you have 0 factors of 2, then it has to be equal to 1 so that it doesn't end up impacting the problem. If you wanted to discuss that further, I'd be happy to do that at another point when we can be in the same room together. All right, so as far as problems like this, x to the third and x to the fourth, what if you had x to the fifth and x to the seventh? So you could think of that as 5 factors of x and 7 factors of x. So there's 7, there's 5, and altogether there would be 12 factors of x. So this again is another example. I didn't do that problem for you, but I'm just kind of showing you the structure that you would use for it. When you have one like this, those numbers end up multiplying, because if you had, say, x to the, I don't want to do the same one, x to the second to the fourth, then that would mean x squared times x squared times x squared times x squared, or xx, 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 and altogether there would be 8 factors of x. Let's do one similar to 19 now. So an example like 19, just make one up. It would be like, say, 8, 10, x to the negative 6, z squared, x to the third, z to the negative 5. All right, so there's 2 different things going on in a problem like this. Remember, this is an example similar to 19, not actually problem 19. One thing, just the fraction 8/10. If I were just simplifying that, I could divide both of those by 2. And this has nothing to do with the exponent rules. If you wanted to show out doing that, you could say 2 times 4 and 2 times 5. So that takes care of the 8/10. And then the x to the negative 6, because it's negative, will come down to the bottom. The z squared is going to stay where it is. And the z to the negative 5 will come up to the top. And so the final answer will be the 2's will cancel, and I'll get 4z to the 7th over 5x to the 9th. So that's an extra example that will kind of show you how to do number 19, so you could try that now. Remember, if you were having any trouble on one like 16, say you had y to the 7th over y to the 10th, you could draw out 7 factors of y and 10 factors of y, and you would get 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you crossed out all 7 from the top and the bottom, then there would be 3 factors of y left, and they are on the bottom. There is nothing left on the top. All right, so I hope that's enough of a brief review of exponent rules to help you get through those problems. The jumbled answers are at the bottom. There is always the potential that I have an error in those jumbled answers, so just double check. If you think that I might have an error, then don't necessarily assume that you're wrong. It could be me. All right, looking at the remainder of this, I'm looking at number 22. Here's an example similar to 22. What if you had 3 times 2x minus 1 squared minus 5 times 3x plus 2? So the first thing I would need to do is consider the 2x minus 1 and the 2x minus 1. Since it's squared, I can write that twice. I'm going to just wait on this. I could distribute that, but I'm going to wait on that. So I'm going to multiply out using 2x minus 1 times 2x minus 1, and some of you might call that FOIL. And I'm going to distribute the negative 5 times 3x plus 2. So 2x times 2x is 4x squared. 2x times a negative 1 is negative 2x. Negative 2x plus 1. And here, 5 times 3 is 15. The x tags along, and then this is the tricky term. Negative 5 times positive 2 is negative 10. Students get the sign on this second term of this negative distribution wrong all the way through calculus. So hopefully you followed that. 12x squared minus 6. Oh, probably don't want to distribute quite yet. Sorry about that. We want to combine like terms in here. And then distribute 12x squared minus 12x plus 3 minus 15x minus 10. And then combine like terms. 15 and 12 is negative 27x minus 7. So this is an example similar to 22, and I think will be enough help to make sure that you can do 21 to 23. Again, do a problem, check your answer. All right, so looking at these problems, you will want to factor them. So if you factor this with a 3x on the bottom and a negative 18x squared on the top, then it would be 6x and negative 3x that fit the puzzle. So 2x squared plus 6x minus 3x minus 9. So 2x minus 3 and x plus 3. So the reason that we're doing these factoring problems up here is because you need them to simplify these expressions down here. So see how 2x squared plus 3x minus 9 is the same problem. So now I know that this factors to 2x minus 3 and x plus 3. And then I'll put in the factors of the x squared minus 9 that you'll get when you factor that. And then probably something will cancel here and leave you with an answer that looks like one of these answers down here. I think I'll do 28 from start to finish because I think a lot of you will maybe struggle with that one. So first off, the factoring of 2x squared plus 6x, you just look for their greatest common factor. There's a 2 in both terms, and there's at least an x in both terms. And then 2x times something has to equal 2x squared, and 2x times something to equal 6x. So if I distributed this, I would get back to that. So now, that's what the top can factor to. And the bottom, 4x, could be 2 times x. And that 2x that's out in front there means that this 2 and this x can cancel. And I would be left on the top with x plus 3 and on the bottom with 2. And then I'd come down here and hopefully find that, x plus 3 over 2. Great. All right, I hope you appreciate a little break from all the geometry we've been doing and practice your algebra skills and make sure you understand it. Be sure to send me a question if you get stuck. You can email me a picture of your work or come to tutorial on Wednesday. And thanks for watching.